Ever wondered what makes your games look so realistic, your videos so smooth, and your AI tools so powerful? The answer lies inside a component called the graphics card, or GPU. Today, on Knowledge Hub, we're diving deep into how graphic cards work, what they do, and why they're the powerhouse of modern computing. A graphics card, or graphics processing unit, is a specialized piece of hardware designed to handle complex visual calculations. While your CPU, the central processing unit, is like the brain for general tasks, the GPU is more like a massive army of mini-processors, each designed to handle thousands of tiny operations simultaneously. This parallel processing makes GPUs ideal for rendering images, animations, and even accelerating tasks like artificial intelligence and scientific simulations. At its core, the GPU pipeline follows several steps. First comes geometry processing. The GPU takes 3D models made up of vertices and polygons and transforms them into the right perspective for your screen. Next is rasterization, converting those 3D shapes into millions of tiny 2D pixels. Then comes shading and texturing, where the GPU calculates how each pixel should look, what color, what brightness, how shadows fall, how light reflects off surfaces, and even how smoke, water, or explosions behave. These operations rely on shader cores, which run small programs called shaders to simulate real-world lighting and textures in real time. A modern graphics card is built from several key components. The GPU chip itself holds thousands of CUDA cores or stream processors depending on whether it's NVIDIA or AMD. Then there's VRAM, or video RAM, which stores textures, frame buffers, and data the GPU needs instant access to. The memory bandwidth of VRAM determines how fast that data moves. GDDR6 and GDDR6X are the latest standards, offering speeds measured in hundreds of gigabytes per second. There's also the cooling system, fans, heat sinks, or even liquid cooling, because rendering billions of operations per second generates enormous heat. Power delivery is another crucial part. High-end GPUs can consume over 400 watts, requiring multiple power connectors and efficient voltage regulation. But a graphics card isn't just for gamers. Today, GPUs are at the heart of artificial intelligence, machine learning, 3D modeling, video editing, and even cryptocurrency mining. Their ability to handle massive parallel workloads makes them indispensable far beyond gaming. And then we have APIs, application programming interfaces like DirectX, OpenGL, and Vulkan. These act as the middleman between the game or application and the GPU, translating software instructions into hardware commands. Modern GPUs also use ray tracing cores, dedicated units that simulate the actual behavior of light rays for ultra-realistic reflections and shadows, once thought impossible in real time. Companies like NVIDIA, AMD, and Intel are constantly pushing the boundaries, adding features like DLSS, deep learning supersampling, that uses AI to upscale images, giving you higher frame rates without losing visual quality. So in short, a graphics card takes raw binary data, transforms it into stunning visuals, and does it fast enough that your eyes see smooth, lifelike motion on screen. It's not just drawing pictures, it's performing trillions of mathematical calculations every second to make digital worlds feel real. If you enjoyed exploring the tech behind GPUs, make sure to subscribe, because here at Knowledge Hub, we break down the hidden science powering your digital life. And as always, stay curious.